we have already learned so many different methods of adding two vectors or more than two vectors, and we learned triangle law of vector addition, we learned parallelogram law of vector addition, we learned polygon law of vector addition, we learned head to tail method, those all we learned. So now in this case I'm just trying to say two special case, all right, two special case while adding two or more than two vectors. Okay, so here the first thing I'm going to talk about is a special case when two or more than two vectors are acting into the same direction. All right, for example, here I'm just going to take two vectors, they are acting into same direction. Acting into same direction means those two vectors are parallel to each other, keep in mind. All right, those two vectors are parallel to each other. Let's say for a while I have a vector A. Okay, let's say this is my vector A, and let's say I have another vector. Let me do with this another color. Okay, I have another vector B. Okay, and now I want to find out what is the resultant of addition of these two vectors and what will be the direction as well. I want to find out both because vector means magnitude as well as the direction. So the resultant of adding both vectors, vector A and vector B, we're going to find out. All right, so what we learned there while adding two vectors by head and tail method, let me tell you, one's head we connect with another's tail. All right, so this is the tail of the vector A and this is the head of the vector B. So I'm going to connect the tail of the vector A with head of the vector B, or you can do head of the vector A with the tail of the vector B, as you wish. All right, so what we do, let's put this B over A. All right, so head to tail. All right, now this is vector B, let's assume for a while. So this is vector A and B. Now after connecting we got a pretty straight line. Imagine this is a pretty straight line, all right, though it's very 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 curved. Anyways, so how do we find out that? All right, we want to find out what is R. Well, I have written like this, but we have already learned one more thing. The resultant of addition of any two vectors in triangle law and in parallelogram law is under root p square. All right, these all are inside the root. P square plus q square plus 2pq cosine of theta, where theta is the angle between those two vectors p and q. So here this A will work as our vector p and this B will work as a vector q. So that time our result will be what? Let's take a look. All right, so P is here A square, Q is here B square. Like if you have vector A and when you square this, then this there is no need to write this, simply it is A square. That's what I write here, and it's now 2AB cosine of theta. Now let me tell you one more thing, my friend. What is the angle between this vector A and B? All right, vector A is acting like this and vector B is also acting over that, exactly. So both are parallel, it means angle between them is 0. When two lines are parallel to each other, then the angle between these two lines is 0. So here simply I'll write cosine of 0. All right, so it's going to be now A square plus B square plus 2AB, and do you know, my dear friend, cosine of 0 is 1. So it's going to be now A square plus 2AB plus B square inside the root, and further I will get it A plus B whole square inside the root, and since it's square, so this square will cancel this root, so I'll get A plus B. Right, I'm sorry, here I need to give the vector sign. Right, here also I need to give vector sign. I'm poor, I'm sorry. Okay, so now vector A plus vector B. All right, so resultant vector is simply the sum of the vector A and sum of the vector B. This is the magnitude of vector A. All right, keep in mind. So magnitude of vector, so magnitude of the resultant is simply the magnitude of A plus magnitude of B. All right, let's find out the direction. Well, the resultant's direction will be what? Let's find out the direction of. Let's find out the direction of the resultant now. The direction of the resultant we used to find out by a formula that was q sine theta divided by p plus q cos cosine theta. All right, this was this formula actually I'm taking from the triangle law, or you say parallelogram law. Right, so q is here B and sine theta is going to be now sine 0 degree, and p is here A and q is here B and cosine of 0. So see here, sine 0 means 0, so whatever is there 0 is going to multiply, so it overall, I mean, the whole this value is turning to 0. So the angle made by the resultant with respect to A, all right, with respect to P, generally it used to be in triangle life, you know. So with respect to P is 0. It means the resultant is just going over it, all right. So actually I try to prove here and then show you, but simply I just want to say that let's say, let me give you an example. Let's say a limousine, a kind of car, right, is moving on a road, all right, for a while. Let's say this is the road. Just imagine this is the road. Let's say limousine L, and this, let's suppose, as a vector L. All right, this is moving with a force, let's say, for a while. Like engine is giving some thrust of, let's say, 2000 Newton for a while. All right, and behind this is a big monster truck. All right, big monster truck. Oh my god. All right, and this is coming with truck T with the force of, let's say, 5000 Newton. All right, so this truck is going to hit this limousine with 5000 Newton. So what will be the resultant? All right, this L vector is being hit by vector T. All right, so that time, you know, what you'll feel that this limousine will move very fast. All right, like you were running, you know, you were running in this direction, and someone is pushing you from the back. So what will happen? You may fall down because you're running so fast. That time you'll move forward so fast. You know why you move so fast? Because you're pushing already this side, and your friend is also helping you to move forward. So what happens? Automatically the resultant gets even faster. All right, so that's a very simple application of two vectors acting into the same directions. That's why you move very fast in some directions. All right, right here I want to tell you one more thing. This is only the case of getting maximum output, maximum resultant. Special case 1 I want to say better as case of maximum resultant. All right, so whenever two vectors are acting along the same direction, I mean to say there is a vector, let's say P, acting towards this direction, and there is another vector Q acting towards this direction. So when you're gonna add both of them, you know what you're gonna do? You're gonna do either head or tail, or like you're gonna, you know, by arranging properly, you'll add triangle. You use the triangle rule. All right, so by doing so, you know, you'll just move this, like here, Q. All right, and that time the resultant will be somehow like this. All right, so resultant will be really short or small when you get some angle, but while adding two vectors, if the angle is 0 degree, all right, that time the resultant will be really huge, and that will be the maximum. All right, I'm going to say here is one vector P, and if you're going to add another vector Q into the same direction, then that time the resultant, you know, is the simply addition of both vectors, and that will be the case of maximum. Keep in mind. All right, that will be the maximum resultant, and any other way of adding these two vectors will be less than this. All right, so in this video I want to simply sum up with two lines. If two vectors are acting to the same direction, then the resultant will be maximum, and we simply add the magnitude of the both vectors as a resultant's magnitude. All right, and direction will be the same as the direction of the first or second vector. And in the next video we'll be talking about the case of minimum resultant.